Okay, this is a video about rules for functions, rules for tables, rules for sequences. And we have two types of rules that we talk about. We talk about recursive rules, where you see the pattern next. And then we have what we call explicit rules, which are going to be in the more familiar y equals situation. So let's talk about the different times we use different rules and how we use them and why. In this pattern, you can see that we are adding 7 each time. And so hopefully you're saying to yourself that this is arithmetic, and that an arithmetic sequence you put it into a next equals now rule is going to have a plus or a minus in it. So to get to the next number, we take where we are now, we add 7 to it. And in this case, we're starting at 5. If I wanted to just get, if this is, the first 4 terms, if I just wanted to get the next term, I would just know that I need to add 7, and I would get 33. That would be fine. But what if I said I want you to find the 50th term? Well, that means I have to do 50 numbers out? That doesn't make a lot of sense. So this is where using a y equals equation, which we call the explicit form, is going to be much easier. So hopefully you're familiar with the form y equals mx plus b, and the n is the slope for what you're changing by. And b is where we're starting, and we also know that as the y-intercept. And we'll talk about that y-intercept more later, but what we're going to do is we're going to take what we're changing by, this 7, and we're going to put it in here for the m. And we're going to take what we're starting at and put it in here for the b. And then if you just insert your y equals, so this is going to become y equals 7x plus 5. So if I want to find the 50th term, then I'm just going to plug 50 in for x and simplify this out to find out what the 50th term would be. Let's look at some more. In this example, we have it in table form, so we can see this is adding 3. Why isn't my pen working? Adding 3, adding 3. So to get to the next value in the table, take where we are now. So if you're at 14 and you add 3, you get to 17. I'm starting at, when x is 0, I'm starting at 5. And so again, to change this into y equals mx plus b form, since this is linear, it's arithmetic because I'm adding each time, I take what I'm changing by, I'm changing by 3, becomes 3x, my slope, plus 5, starting at 5. So it's pretty easy to just see that the first number goes into the first position, the second number goes into the second position in terms of the mx and the b. So what happens now if we have a situation where it looks like we're multiplying each time? In this case, hopefully you can see that we're multiplying by 2. So this is going to be a geometric or exponential situation. So to get to the next thing, I'm going to take where I am now, and I'm going to multiply by 2. You can see that. starting at 5. So again, your starting at value is always when x is 0. What is your y value? Now the general form for an exponential equation is y equals a times b to the x power. And in this case, the a is your starting number, and the b is your factor, what you are multiplying by each time. So unlike with the linear where it just first into the first position, second into the second position, in this case you have to think a little bit more. Your factor, what you're multiplying by, is going to go into the b position, and your starting at is going to go into the first position. So this becomes y equals, I'm starting with 5 things, and I'm going to multiply it by 2, because I'm doubling it, and that's to the x power. And make sure that x is an exponent, so it has to be smaller, it has to be up in the exponent position. Don't be confusing and have it bigger and down low. Here's another situation. Hopefully you can see pretty quickly that we're subtracting by 7. Okay, so to get just to the next item in the list, take where I am now, and I'm minusing 7 each time. And again, I'm starting at when x is 0, so I'm starting at 15 in this case. Since I'm adding or subtracting, this is arithmetic or linear. Okay, so you're going to use y equals mx plus b form. So how much am I changing by? I'm minusing 7 with my x plus 15, what I'm starting at. So again, slope, y-intercept. You do need to make sure you have a negative 7x because you're subtracting 7 each time, so make sure you have that. Let's see here. 100 to 80, and 64 to 80, and then 51.2 to 80. Excuse me 1 second. So this is a trickier situation because it's harder to see right away that you're adding or subtracting something, and hopefully you can see that you're not adding or subtracting something consistently. So probably means we're multiplying by something, but we're multiplying by something that's going to make it get smaller. You can sort of see, because there's nice numbers to start out with here, that to go from 100 to 80 will, if you take the second number and divide it by the first number, so if you did 80 divided by 100, you can see that that's 0.8 or 80%. And if you think that that's what you're multiplying by each time, I'm multiplying by 0.8, then just do the third number divided by the second number. So you could do 64 divided by 80. If you do that out in your calculator, you'll see that that's also 0.8, 8/10, or 80%. So we can see that we're multiplying by 0.8 each time. So if you start to see a pattern and you're not sure what it is that you're multiplying by, then you can always take the second number divided by the first, the third number divided by the second. So divide this way, divide this way. You could take the fourth number and divide it by the third. And if you're getting the same consistent multiplier or factor, then that's what you're, in this case it's a decay factor because it's getting smaller. That's what your factor is going to be. So this is going to be exponential, because we're multiplying each time. To get to the next value, we're going to take where we are now, and we're multiplying by 0.8. No problem there, starting at 100. So remember, to get to the y equals, you take your starting at value first. I'm taking 100 things, whatever they are, and I'm multiplying by 0.8, and I'm going to raise that to the exponent of x. Okay, so the starting at goes first, the factor, which you're multiplying by, goes to the x power. What else do we have here? So the general pattern for a linear function which matches with an arithmetic sequence is next equals now plus m plus your slope, and you're starting at b. And so that goes directly to y equals mx plus m goes here, your starting at goes down here. Okay? In an exponential pattern where you're multiplying, so linear, you're adding or subtracting. Exponential, you're multiplying. It's a geometric sequence. Next equals now times what you're multiplying by each time, starting at a, or y equals starting value a times b to the x power of the exponent. Make sure you have those written down. Caution. So it's very easy for students to only look at the y table, the y part of the table, and just say, oh look, yeah, look, I'm adding 3 each time, super easy, no problem. I know that this is going to be next equals now, plus 3 starting at, and a lot of us will just jump automatically to whatever number's at the top of the y column, starting at 5. But here's why the caution symbol is up. Okay? Caution, caution, caution. Remember we said the starting at value has to be when x is 0. Well, right here, x is not 0, x is 1. So that's not technically our starting at value. So let's erase that. Erase yours or cross it out if you need to. And let's see what happens if we work backwards up 1. So when x is 0, what's y? So what would this number be so that when I add 3 to it, I get 5? Or if I subtract 3 from 5, I get 2. So you need to make sure that your starting at value, starting at, is when x is 0. So in this case, it's 2. So my y equals equation is going to be 3x plus 2. Good to remember. What if you want to do a U-turn and go from a y equals equation to an x now equation? Should be pretty straightforward. Take the information from the equation and insert it into the recursive form. Remember, recursive is the next now. So to get to the next thing, I take where I am now, and I'm just going to take this slope and insert it in here. And it's going to be a positive 2, starting at negative 4. There's my starting at value. And I'm going to take my exponential form, and I'm going to say next equals now, and this is what I'm multiplying by each time, times 5, starting at, here's my starting value, 4. So you should be able to go both from a next now to a y equals, and from a y equals to a next now. And that looks like it's it. Remember, recursive form is the same as a next equals now form. And the explicit form is the same as a y equals equation. Nice job and good luck.